So today we're going to be talking about functions. So what is a function? It is a set of points that are defined as a function when each x value has only one y value. So each x only has one y. So students sometimes have problems understanding what this means. So we're going to break it down for you in a couple different fashions. Okay. What it really means is we have an x and a y. And we're going to symbolize our x and y as x is going to be our guy and y is going to be your girl. And this would be a function right now because this one x has one y. So the guy has one girlfriend. However, what she doesn't know is that this guy has got a girlfriend on the side. And this is a problem. Okay, because this is not a function, because one guy cannot have two different girlfriends. One x cannot have two separate y's. Okay, that's no good. So guys, you got to stay loyal. It's just what it means to be a function. All right, let's look at a different scenario. So we have another x, this time this young gentleman and this fine young woman. What he doesn't know is that she has another man on the side. And this is okay. All right, this is a function because the guy only has one girl, and that's the function. But the girl can have as many guys as she wants. It doesn't matter. It's okay. It's fine. Okay. So because the y has two different x's, that's okay. Just the x cannot have more than one y. Okay, so a guy cannot have more than one girlfriend. So let's look at this in terms of some math stuff. Okay, so this is a function, I guess, tree. Okay, so on the left are the x's, on the right are the y's. So we would figure out whether or not this is a function or not. Okay, so in the first one, this would be a no. Okay, the reason being is because 6 on the left is seeing both 6 and 9 on the right. So that's not good. He can't cheat on his girlfriend. Okay, in the middle, would this be a function? The answer is yes. Because although 3 is seeing both -1 and 0, that's okay. All right. And lastly, the last one here, would this be a function? And the answer is yes. All right. Each x has only one y. So that means it is a function. All right, so that's kind of the terminology we're looking for. Yes, it is a function because each x has only one y, or no, because an x has more than one y. Okay, let's look at this in a different scenario. We have a data set, okay, of points. So we're looking for the x's and if any of the x's have more than one y. Okay, in the first one, we got 3, 4, 5, 6, and 2, 6. Is this a function, yes or no? This is a function because although 6 is seeing both 5 and 2, the 6 is a y. Each x has their own y. All right, the next data set. Is this a function? This is not a function because 2, an x of 2 is seeing both 6 and 1, which is no good. All right, the next data set. This is in fact a function. All right, each x has their own y, and there's no doubling up. And lastly, is this a function? Now, many people think this is not a function, but it in fact is. Okay, although -3 is seeing 6, that's the point. Okay, what you can think about this is, -3 sees 6 first period, and then sees her again later, 8th period. Same point, same girlfriend, just at different times of the day. Okay, so this would be a function. All right, so there's one way of looking at it through data sets or effective trees, or function trees, sorry. But there's another way. Let's say you have a graph, and it's kind of harder to see because you don't have the points of the numbers in front of you. So that's where we get to this. If you have a graph, to figure out if something is a function, you go through the vertical line test. Okay, so what you do is you can take an imaginary vertical line, and you run it through the entire graph. Okay, as long as the graph doesn't touch more than one point, your line doesn't touch more than one point on the graph at a time, it will be a function. So here's our imaginary vertical line. We make it go through the whole graph at the same time. Right, and at no point in time did that line touch more than one part of the graph. So that would be a function. We do it again over here. As we move along, right about there. Now the vertical line is hitting more than one spot on the graph. And this would not be a function. It does not pass the vertical line test because the x value of -6 has a y value of 6 and of -6. And that means one x cannot have more than one y, thus it is not a function. Okay, let's take a look at this. Would this be a function? Yes or no? That'd be a no. All sorts of no. All right, would this be a function? It would be right up until that little hook part on the top. So this would not be a function either. Okay, now you have 3 more graphs on your notes. So run the vertical line test through those 3 graphs and figure out whether it is yes or no, whether it is a function or not a function. And then we'll start up the video again. All right, so your answers for those should have been no, no, and yes. Okay. All right, moving on. The other thing that we're going to see, we got 2 more things to see in this video. We're going to be looking at domain and range of the graphs. Okay, so domain is from left to right. So domain is all the x values that exist in a graph. So we go from left to right because the x values are the axis that goes from left to right. Okay, and x values are associated with domain. So if we start on the left and we go to the right, we want all the values in there. Okay, so our domain is going to be from -9 to +10. Now you'll notice when we when we write this down, we have brackets and parentheses. So let's explain what those are. This is a lot like inequality signs. Okay, when you did interval notation. If it is included in the domain or included in the graph, it is a bracket. Okay, so that would be a solid line or a solid point on the graph. If it is a hollow point or is an empty point, like the one for 10, it would be a parentheses. Okay, so if you go from left to right on the graph, the graph exists on the x-axis from -9 to +10. Okay, now the range is the y values of a graph. So we go from the very bottom of the graph, so the lowest point on the graph, not from where it started on the left, but from the lowest point of the graph to the highest point of the graph. Okay, we look at the range, we're looking for the lowest point, which is at -4, to the highest point, which is at +9. Again, you'll notice that because it's a solid line graph, -4 is going to be a bracket. Because it's a hollow point up at the top, at 9, it's going to be a parentheses. Okay, so look at another example. All right, what's the domain and range of this? Okay, so domain again is going to be from left to right. So we go from the left to the right. All right, and our domain is going to be from -7 to +9. You'll notice that they're both brackets because the graph you're looking at is a solid line and not an empty hole. Okay, for a range, go from the bottom to the top. A little bit like Drake, we started at the bottom, now we're here. Okay, that was bad. Okay, so you have from -3 to +6. Again, they're both brackets. All right, so let's look at some of the examples on your page. All right, you have domain and range of this graph. So the domain, again, going left to right, so left to right. Okay, so the domain is going to go from -6 to +7. The -6 is going to be a parentheses, the +7 is going to be a bracket. The range, from bottom to top, it's going to be -6 to +8. Now at -6 is going to be a parentheses and +8 is going to be a bracket. All right, we got 2 more examples. I'm going to throw in something else that's going to be on the test as well. So domain for this one, all right, you might want to try these first and then come back. All right, so if you come back, hopefully you've tried it on your own. For the domain, you're going from left to right. So it's going to be from -7 to +10. The -7 will be here, the bracket, +10, the parentheses. The range from the bottom to the top. So the bottom is going to be negative 8. The top is going to be positive 8. All right. The negative 8 is going to be with a bracket. The positive 8 with the parentheses. All right. And the last two things, this is a little bit tricky, but it's really pretty simple. Looking for f of 4. So what we're looking for is on the x-axis, go to 4. When you get there, what is the graph? What is the y value for the graph at positive 4? So if you go to the right by 4 and see the graph is below the x-axis, at the y value, it is at negative 8. Okay. At negative 5, you're looking on the graph at negative 5 on the x-axis. You can see that the graph crosses the x-axis at negative 5, which means the y value for the x of negative 5 would be 0. Okay. All right, one more slide here. So we got the domain started on the left, goes to the right. All right, so our domain is going to be from negative 7 to positive 9. Both are going to be parentheses. All right, the range starts at the bottom, goes to the highest point of the graph. So the range is going to be from negative 9 to positive 5. The negative 9 is going to have a bracket. The 5 will have a parentheses. And then we got the last two things. So g of 6. So at 6, what is the y value if x is 6? So we look at the x value at 6 on the x-axis, looking for where it is for the y value on the graph. It is going to be at negative 4. And then for negative 2, if we look at the x-axis at negative 2, what is the graph going to be at? It is at negative 8. And that is it for the notes. There is a quick practice. Do that, and then we are done with all the new stuff. Test will be on Friday.